Hello and welcome to the Planetary Spectrum Generator video tutorials. I'm Sara Faggi, member of the PSG team, and if you are interested in learning how to operate PSG, you are in the right place. The subject of this video is getting to know how to initialize and run PSG. For more information, you can refer to the first chapter of the PSG handbook. PSG allows to compute spectra at a broad range of wavelength from the UV X-ray to the submillimeters, and is also allowed modeling of mass spectrometry spectra. PSG operates with an advanced radiative transfer multiple scattering models, and it also includes realistic instrument and noise simulation. The tool permits to retrieve and analyze data with the model retrieval packages. The Planetary Spectrum Generator can be operated in several ways: via the web interface, via the API, a flexible application program interface which is accessible from multiple scripting languages, and by the Docker visualization system. More information about the API and the Docker will be provided in Chapter 10 of the handbook and the related video tutorial. The parameters that define a PSG simulation are all contained into a single configuration file. Typically, this is called config file, which is readable text file. The full purpose of the online web interface is just to read, edit, and save this configuration file before calling the PSG server and requesting a simulation. If you are a first-time user, the easiest way to start a simulation with PSG is by loading the pre-saved templates configuration file, and this file can be found in the list menu just below the main module of PSG. Once uploaded, you can run a calculation by clicking on Generate Spectra. Simulated spectra and graphs will appear below. Any parameters of the desired simulation can be modified by clicking in Change Object, Change Composition, or Change Instrument buttons, each of which will redirect you into the three main PSG sections. After any change, you can save them clicking on Save Setting, discard them by clicking on Cancel, and you can also reset everything by clicking on the Reset button in the main page. Also, always in the main page, it is possible to download the configuration file by clicking to the Download Configuration button. This will save it in your own computer, permitting you to view the content, to edit it, and to use it for future operation by uploading it in PSG. When all the parameters of your simulation are defined, once again, you can run your calculation by clicking on Generate Spectra. The main outputs of the simulation are text file, formatted as multi-column table with an header defined by the pound symbol. These output tables are read by the PSG internal graphic module, and they produce the spectral plot that you can see below. A full description of input and output file can be found in Chapter 1, the PSG handbook. PSG works on a very simple and linear principle. Each section calls a specific set of modules of the PSG server, and all take input from the same unique configuration file. Let's now have a first look at these three main sections on the PSG web interface: the geometry, the composition, and the instrument parameters section. In the Object and Geometry window, which is appearing by clicking the Change Object button, the upper section defines the object that we are interested to study. Any parameter defined in this section will appear in the configuration file under the label Object or Geometry. In this section, it is possible to select the type of solar system object, as for example if you're modeling a planet or a comet or an asteroid, and perform similar ephemeris operation. Once the geometry information is retrieved, all the fields of this section will be populated in the PSG config file, and PSG can then perform realistic 3D orbital calculation, which is shown in the bottom panel of this window. The atmosphere and surface window appears when clicking on Change Composition button. In this section, you can define the parameters referring to the atmospheric and surface composition of the object you are studying. Any parameter defined in this section will appear in the configuration file under the label of atmosphere and surface. The user can also select between two main atmospheric models: the expanding coma, that is generally adopted in target-like comets, or the hydrostatic equilibrium, which is atypical for planet. Once selected atmospheric model, its composition can be then defined. For example, the user can define the surface pressure level or the cometary activity in case of a comet, as well as the molecule to be considered for the simulation. Details on the atmosphere and the exospheres handled by PSG are discussed in Chapter 3 of the handbook. The user can also select from multiple surface scattering models and add surface composition. Surface modeling are presented instead in Chapter 6. After defining the simulation geometry and the target composition, well, then you can move to the third and last section, which is the parameter referring to the observatory and the instrument that you're using to observe your object. This section is accessible via the Change Instrument button, and its parameter will appear in the configuration file below the label Generator. This section allows you to select from a list of predefined instrument templates, and eventually you can modify them, creating your own instrument setup. The core parameters of this section are the wavelength range, the spectral resolution, and output intensity units. And when including the noise simulation, also the detector parameters. PSG indeed include the possibility to include realistic noise calculation. More details are in Chapter 8. Hopefully you have found this short video instructive. We encourage you to explore the PSG handbook and also the related video tutorial and material. Ad astra, and thank you!